Hello everyone, this is Veena Gandhi from BC Science Department. Welcomes you in Files in C Part 3. In Part 2, you will learn the input and output function for text files. In this video, you will learn input and output functions on binary files. The topics covered in this video are input and output operation on binary files. In that you will learn fread function and fwrite function. Then how to access the file randomly. For that functions are rewind, ftail, fseek, and examples on about topic and assignment. Input and output operation on binary files. In previous video, we have already learned text and binary files and difference between them. Now, binary files are very similar to array of blocks or structure, or you can say array of bytes, except these blocks or structures are in a disk file rather than in an array in a memory. Now, binary files have two features that distinguish from the text files, that you can use or access any block or structure in the file, or you can change the contents of any block in the file. After opening the binary file, you can read and write a block or structure, or you can search specific position in the file. A file pointer points to record 0 or byte 0 when the file is open when the file is open. Now when you open the file, we use the fopen function, but in fopen, in the mode, you can specify RB, read, open in the read mode, and add the B for binary file. The C language supports the two functions for binary files, fread function and fwrite function. A read operation reads the block or structure where the file pointer is pointing to. After reading the block, the file pointer is moved to point at next block. Similarly, in write operation, data will be returned to the currently pointed to structure position. After write operation, the file pointer is moved to point at the next block or next structure. Fread function. This function reads a specified number of bytes from binary file and places them into memory at specified location. Now, fread function accepts 4 parameters. First parameter is pointer. Pointer is a reference of an array or structure where the data will be stored after reading. Second, size. It indicates the number of bytes to be read from the file. Next, number of times the record will be read. And last is a file pointer, pointing to position from where the records will be read. You can see in a figure, before reading, file pointer is here, and after reading, file pointer is moved number of bytes equal to that size of a structure, size of a block. So any read operation reads the currently pointed to structure and moves the pointer down one structure. Fwrite function. This function is used to write records, or you can say sequence of bytes, to the file. A record may be array or it can be a structure. Now, same as fread function, fwrite also accepts 4 parameters. The first argument is pointer. Pointer is the reference of an array or structure stored in a memory. Second, size. It indicates the total number of bytes to be written. Next, n. N is the number of times record will be written. And last, file pointer, pointing to location from where the records will be written. You can see in this figure, before write, file marker is here, file pointer is here, and we want to write one student record. After writing, file marker is here. This file pointer is moved number of bytes equal to the size of a student structure. So any write operation writes to currently pointed to structure and moves the pointer down one structure. Let us see C program using fread and fwrite function. Here I am using Turbo C++ compiler. Now, in this program, I want to store student record which contains S number, S name, and marks. So, the first include header file stdio.h file, then instruct student, define the members S number, S name, and marks. S number of int type, S name is character array of 30 characters, and int marks. Now, in the main function, define array of structures. So, struct student S of 60. In int and then define a file pointer, file *fp. Now, open the file student1.bin binary file, you can say, in a write mode, write binary mode, B for binary, write in binary mode. So fpf open student1.bin in write binary mode. Now I want to accept only two records for the simplicity. So for I equal to 0, I less than 2, I plus plus. The interpretation of student1, I plus 1. So student number accept the student number, scanf %d ampersand s of I dot s number. Then accept the student name, so scanf %s s of I dot s name. Then accept the marks, so scanf %d ampersand s of I dot marks. Then we want to write this now record on in a file. So use the function fwrite. Where the record is stored in array. So ampersand of s of I. So provide the address of s of I. Then size of s of I. Size of record. Only one record we want to write in a file pointer. So fwrite accept 4 parameters. First pointer, second size, then n how many records you want to write, and file pointer. After that, close the file. Again, open the file. Student1 bin in a read mode, read binary modes. Okay, I equal to 0. Now read the file till we get the end of the file. So while fread, again same as the fwrite function, it accepts 4 parameters. First, pass the structure where we want to store data. After reading the data, where you want to store. So we want to store in again in a S array. So pass the address of S array, then size of structure, and then how many records you want to read from the file. So 1, and file pointer. So after reading that recording to structure s of I, print that details. So printf student number equal to %d s of I dot s number, printf student name % s of I dot s name, and printf %d s of I dot marks. Increment the I plus plus. So read the next record from the file and print on the screen. So fread will read the file till it get the file end of the file marker. After that, close the file and return 0. Let's run this program. Suppose student number 10, suppose name, now you can see the here output. Name, number, name, and marks are display of student, both the students. Now if you open the file, you can see here all records are stored like this binary file. You cannot read this file easily. So this way we can use fread and fwrite function. Next topic is random access to files. Now we can access files in two ways, sequential manner or random access. In sequential access, we scan the records record by record. Means we can traverse first record, then second record and third record like that. Means if we want to access 10th record, we have to traverse first to 9 records. But in random access, we can directly access 10th record. There is no need to traversing first 9 records. So in C language, random access file allow us to read or write any data in the disk file without reading or writing every piece of data before it. Means we can quickly search for data, edit it, or even we can delete it in the random access file. But we need some few functions to access the file randomly. C language supports 3 functions to access the file randomly: ftail, rewind function, and fseek function. Let us see this function one by one. The first function, ftail function. This function tells the current position of the file pointer in random access file. Now the function takes file pointer as argument and returns the current position of the file pointer in terms of number of bytes from the beginning of the file. Syntax: n equal to ftail of fp, where fp is a file pointer. Now n would give the relative offset in terms of bytes of the current position. This means that already n bytes have been read or written. You can see in this figure, it's at the beginning of the file and it shows the current location 16. Means already 4 records have been read or written in the file. Next function, rewind function. This function resets the file pointer position to the starting of the file. The syntax: rewind, accept the file pointer. Now, suppose if you call the function rewind fp, after that if you again call the function n equal to ftail fp, then n will be assigned the value 0. Means what? First file pointer is reset to 0 and ftail will tell the current file pointer position. It is 0. So when you rewind the file pointer position is set to the starting of the file. The first byte in the file is numbered to 0, second byte as a 1, and so on. Now this rewind function helps in reading a file more than once without having to close and open the file. Now whenever we open the file for reading or writing, a rewind operation is done implicitly. You can see in this figure, before rewind, file marker is here, and after rewind operation, file marker is placed at the 0th byte or starting of the file. Next function is fseek function. Fseek function is used to move the file pointer to a desired location within a file. A syntax for fseek function. Fseek function accepts 3 parameters. First, file pointer. Second, offset of long type. The offset defines the number of bytes to move from the position. And third parameter is the position of int type. It defines the location in a file from where the file pointer needs to be moved. The position can take the following values. First value 0. 0 means value constant is 6 set. Means you can move the file pointer from the beginning of the file. Second value is 1. Means seeker, means from the current position you can move the pointer. And 2 means seek end, you can move the file pointer from the end of the file. Now this offset can be a positive or negative. If it is positive, means move the file pointer in forward direction, and negative means move the file pointer in backward direction from the position specified. So when fseek is called, it sets the file pointer to specified position in the file given by the file pointer. Now the offset argument specifies that number of bytes to move from the origin specified by the position. For example, suppose fseek fp, 10, 0 means move the file pointer 10 bytes in forward direction from the beginning of the file. Move the file pointer in forward direction 10 bytes ahead from the starting of the file. F6 fp comma minus 10 seek end means move the file pointer in backward direction 10 bytes. So when the operation is successful, F6 returns 0 value, and when we attempt to move file beyond the boundaries, it returns the -1. You can see in this figure, file pointer is here, starting of the file. If we say F6 sp comma 4 into size of structure type comma 6 set, means it tells that to move the file pointer 4 records ahead from the beginning. So you can see the file pointers here, 4 records ahead in forward direction from the beginning of the file. 6 set means from the beginning. Now second, you can see here F6 sp minus 4 into size of struct type and seek end means move the file pointer in backward direction from the end of the file. How many records? So minus 4 means in backward direction. So 4 records move in backward direction from the end of the file. So you can see here file pointer is here. So from the backward it moves in 4 records in backward direction. Now file pointer is now here. Now next command is F6 sp comma 2 into size of struct type seeker. It means from the current position move the file pointers 2 records ahead. So you can see here file pointer is here in this location. Let us see C program using ftail rewind and F6 function. In this program, I want to show position of the file pointer after using F6 and rewind. So first I declare a string of 25 characters. I initialize with the welcome to BCA Science. After that, file pointer is defined, file *fp, and clear the screen. A SCR function is used in the header file conio.h console.io.h file. Then open the file in write mode in binary format. So file.bin open in write mode. After that, you can write a string by using fwrite function. So fwrite, pass the address of string, length of a string, how many times you want to write, one time only, and then file pointer. After writing a string, I am checking where is the file pointer. So file position at byte %d ftail fp. Then move the file pointer to the starting. So rewind fp. It will set file pointer to 0 position. So I am printing that file position at byte by using the function ftail fp. Ftail tell the function ftail fetch the current position of the file pointer. Now from that position I want to read the string. So fread string, fread, pass the address of string, then how many characters I want to read, then how many string I want to read, and then file pointer. After that I am printing a string. Then use the F6 function to move the file pointer to the end, and from that end move backward by 5 bytes or 5 characters you can say. So F6 fp minus 5 seek end. Then print the file position pointer. So print the file position at %ld and then use the ftail function to get the file pointer position and then get ch. Let us run the program. So you can see after writing a string into file, it shows the file pointer at 22 byte. Then I am rewinding the file, so file pointer will come 0. Printing a string from that file, and then moving the file pointer end of the file and moving in backward direction by 5 bytes. So it will show 17 byte here. This way we can use the fseek, update and rewind function. Let us see assignment. Short questions. What is the purpose of rewind function? Straight true or false. Uptil moves the file pointer at the end of the file. Long questions. Explain fread and fwrite function used for binary files. Explain the random access function used in files in a C language. Now this is the end of the file chapter. If you like this video, please share and subscribe. And please give your feedback in comment box. Thank you for watching.